CMO of Useful Technologies. And yes, like I said, you guys are welcome. The webinar I've started, and we're going to continue like this. So Usefull Technology is a tech company based in Lagos and Benin that offers services in areas of tech. It offers tech solutions and digital products to individuals, companies, institutions, and businesses. So the different areas that Usefull Technology offers services on has to do with digital marketing, data science and analytics, web and mobile app development, 3D modeling of products and models, and also design. And also we have the digital marketing aspect of the company, which, yes, I'm the CMO, the one in charge there. Yes, but one thing that's very dear to us is our training. The training we offer to institutions, individuals, and also businesses. Why do we offer these trainings? We offer it just so that people can gain the skills that we have in our company. So, I mean, the different aspects of the training has to do with the different departments we have in our company, which has to do with data science and analytics, digital marketing, 3D modeling and design. And also we have mobile and app development for businesses. So yes, back to the webinar. We have Alex Inoma here, who is going to tell you guys about 3D printing and how 3D printing is a fourth revolution technology. Yes, but the webinar is going to be divided into two sections. The first section is going to be, yes, on the 3D printing old stuff that Alex is going to tell us about, while the second session will be on Q&A. So feel free to ask your questions, but I will encourage you to type your questions on the chat. Yes, so once it is time for the second section, I'm going to read them up and Alex is going to answer the questions. Yes, so not to steal the show from Alex, who has been here patiently waiting for all of us. And yes, so Alex, you can take us through the whole revolution of this technology, 3D printing and everything. So Alex, over to you.
All right, thank you very much, Barry. And I think that's a go ahead for me to kick it off. So this is the 3D printing seminar. It's going to be a very interactive seminar. That is the plan. That's always the plan with this. But because of background noises that will come from the limitations of Zoom and stuff like that, we'll tell you to hold on with your questions till the end of the seminar. That being said, please can you turn off your mics or mute so that we can avoid other sounds while doing this seminar. All right, so welcome to today's seminar. My name is Alex, as Barry has said, and I also work as the 3D printing instructor for Usefull Technologies. All right, so today's seminar is actually because of what's going on in the world right now. Like many people are hearing about COVID-19, many people are hearing of how 3D printing has been used to tackle these challenges, and people are wondering, what is this 3D printing? What is it about? So Usefull Technologies and myself decided that this would be a good time to let people know what 3D printing is all about. So this is a bit of my bio, but I won't, since Barry has already talked a bit about me, I'll move on to the training itself. So what are the highlights of this training or this orientation? I like to have a form of contract when I am having an orientation with people. I like to have I call it an upfront contract, actually, it's a popular term. And with this contract, you should know what you would gain at the end of this seminar or orientation or whatever it is, okay? So today you have just 3 things that I want you to carry home, no matter what happens, no matter what I say here, carry these 3 things home. And the first is, what is 3D printing? The second, why is it a revolution? And the third, what are the applications? And I'm sure a lot of people have that in their minds. Like most people want to know, what can you use 3D printing to do? Those are the things that we will discuss today. All right. So before we can start talking on 3D printing, I need to give you a bit of history. And trust me, this is not going to be like one of those boring history classes where they explain. No, this is just a brief history so that you can understand where 3D printing came from and so that you can understand how it's moving forward. All right. So in the 1970s, Hideo Kodama presented the concept of 3D printing. This was the very first time 3D printing was stated. The concept was stated, the machine was built for 3D printing. However, Kodama was not fortunate enough to patent his product, so that era passed on. And before Kodama, 3D printing was just fictional. So people would say, I'm going to print something out of nothing, and you see it in movies and science fiction, and you're like, wow, 3D printing, even cartoons had it. But from Kodama and then 1980s, where we started having the first 3D additive manufacturing or 3D printing equipment, we started seeing some real machinery in that area. So let's look at the 1980s. We have 1984, where we have Chuck Hall. Chuck Hall is known by many to be the father of 3D printing. He patented the first working 3D printer, which is the stereolithography apparatus, SLA. All right. And in 1988, Scott Crum of Stratasys developed the FDM. Now, these two men are seen as the big names in 3D printing, and they dominated the sector for over 20 years thanks to their patent authorities. Now, okay, here is a picture of the first 3D printer that was made by Stratasys, the first working 3D printer. You will see it's even, so the beauty of technology is that technologies rely on each other. So at the time when they were making 3D printers, they were also working with the first computers that are being made by Apple and stuff like that. So technologies were being formed as at then. Then in the 1990s, something happened. You see, so people wanted to create their own forms of this technology because Scott Crum and Chuck Hall had patented a particular type of technology. So if you want to use it, you would need to pay them royalties or to get their licenses and stuff like that, which would now hike the prices of the printers. So people started developing new technology so that they could have their own patents around 3D printing. So you started having technologies like SLS and DMLS coming up and several others. Moving on from 1990s, we have 2000s. And trust me, this is just as brief as the history can be. There's a lot more to know about it. We have the RepRap movement and all that, but you can research on that on your own. But what I want to take note of is 2009. Now, in 2009, something great happened. The FDM patent expired. Now, I call it great because it helped 3D printing grow, but of course, for the companies, it was a problem because normally 3D printers were very expensive because you have to remove a percentage and pay to the company that created the software, then you pay some other bills and here and there. So that adds to the cost of the machine. But in 2009, the patent of FDM expired, and in 2014, the patent of SLA expired, which means that printers' prices dropped from about $250,000 to about $5,000 for those type of printers, of course. I'm just trying to give you the perspective of how serious this was in the world. Like that kind of major drop was not something that could be ignored. So 3D printing revolution started where many companies, and the big names in 3D printing, Ultimaker, E3D, MakerBot, were founded post 2009 because it was now a commercially viable process or sector to go into. And then in the 2010s, we started seeing metal and multi-material 3D printing gaining traction. So we started seeing printing of ceramics, started seeing bioprinting, started seeing metal printing. People were forming different materials for 3D printing, all right? And that is where we are today. So the 3D printing industry has moved from just something that Chuck Hall was working on in his lab to something that is a worldwide technology today. So what is this 3D printing? And before I go into that, I would like to let you read this. Now, this says that 3D printing is disrupting the $12 trillion manufacturing industry, and companies like Ford and Siemens are training workforces to adopt these skills and in this technology. What I would love you to take note of, and personally I like to look at money, is the $12 trillion there. I'm sure many people here are Nigerians. I'm not sure $12 trillion has a name in Naira, but it's a lot of money. And that's the sector that 3D printing is trying to disrupt. And this was given by a journalist at CNBC. This was his report. And this shows that 3D printing is not only something that is fun or something that people are going to, it shows that companies are looking for it to adopt the technology. All right. So let's give you the definition. The definition of 3D printing, it is as simple as can be, a process of making 3D solid from a digital file. And that's why I chose this picture over here. this picture is like a very simple explanation of 3D printing. If you look at the monitor, you see a file there of a 3D object, which is the Eiffel Tower of Paris. Hope to be there one day. You see, so that's the digital file. You see the process, which is the printer, the orange. So that's an SLA printer over there on the other side. And then you now see this 3D object that came out of the process, which is the three-dimensional solid object. All right, so this picture summarizes the 3D printing concept. Is that a question? Okay, Osage, can you turn off your microphone so that we can continue?
You're here by the grace of Turbo. And how do you repay his charity?
All right. So I'll try to continue. I hope that Osage can do something right now.
Oh, Loki!
His name is Josh.
All right, so popular types of...
Little Josh with the big... Gay Josh or other gay Josh?
Just Josh. Josh Wheeler. You know what you need, Turbo? A win. Get rid of the stank at the feet with the anti-curse.
All right, thank you, Osage. So popular types of desktop 3D printing. We have the FDM and the SLA. We have the FDM and the SLA. The FDM is called fused deposition modeling. The name FDM was patented and trademarked by the company that founded it, which is Stratasys. So because of that, the company has rights to the name. Therefore, other manufacturers formed the name fused filament fabrication so that they can have a way of representing the technology on their own end. Now, another form of 3D printing is SLA. SLA is, and sorry, this is distracting me. I'm trying to mute him, but it's not working. All right. So I will explain SLA a bit with this next slide. SLA is a photochemical process by which light causes chemical monomers to cross-link together to form polymers. That is a lot of chemistry, and I'm sure people are like, what's all this? But basically, SLA uses UV light to harden liquid plastic. So it has the liquid plastic in resin form, and the light hardens it layer by layer. That's as simple as you need to understand it. So that is the SLA, and you can see the SLA machine inside. This hatch stuff is the plastic that it's forming. All right. Then we have the FFF or FDM. So we have fused filament fabrication. Now this is a separate process that involves continuous laying of filament on a 2D plane to form a three-dimensional object. What do I mean? What do I mean? All right, so let's picture a regular printer, like your ordinary printer, inkjet printer. If you put in a piece of paper and tell it to print, it brings out ink continuously on a single plane, and when it's done, it stops. So that process that it did of forcing out ink on a single plane is actually a first layer of forming a 3D object. So 3D printing, instead of having a single cycle, has continuous cycles that lay layer by layer, and instead of plastic, instead of ink, it releases plastic. So how does it release this plastic? There's something called a temperature-controlled heater. Now, a temperature-controlled heater is what makes FDM unique. As against other technologies, FDM has a means of melting the filament, then releasing it into the atmosphere through the nozzle. Once it's released into the atmosphere, it immediately solidifies, which then forms your three-dimensional object. So it's a simple solid, melts, and then releases to form another solid. All right? And that is the process around FFF, or you can call it FDM. I want to keep using this acronym so you get used to the terminologies. So what more is there to know? Why is it included in the fourth industrial revolution? So many people ask me, what's up with this fourth industrial revolution? What are you talking about? Why do we need to care about the industrial revolutions and stuff like that? So I would like to talk a bit about the four industrial revolutions very briefly. The first industrial revolution, I'm going to focus on manufacturing, because the industrial revolutions happen in many sectors, but I'll focus on just manufacturing. So the first industrial revolution included basic mechanization. So we had the steam engines, we had looms and stuff like that, just basic mechanization processes. So people started learning how to burn fuels, how to do stuff that would create energy and stuff like that. All right. But by the second industrial revolution, something great happened. And I like everybody to take note of this. That is when mass production started. And that is why consumer goods are a thing. So a man named Henry Ford brought up the concept of mass production. Henry Ford was the founder of Ford Automobile, and he believed in democratizing the automobile for everybody. Everybody should have a chance to drive a Ford car. And that was the first mass production assembly line in the world. And it's had many others in jewelry and cosmetics coming up, even mass production of chocolates coming up within that era. So that was an industrial revolution of its own. Now, the third industrial revolution was around automation, which kind of we are living in today. We see many, especially in Nigeria, we see many companies focus on having robots in their labs, in their factory spaces, and having things happen automatically with humans supervising. But it still has its limitations. For instance, as I said, humans must supervise. It also has limitation of you having a particular plant being able to do a single thing, not being very flexible. All right. So what is in the fourth industrial revolution? In this fourth industrial revolution, that is where we are and that's where we are going. You can even see the Wi-Fi symbol signifying it. Now, in this fourth industrial revolution, we believe in Internet of Things, digital manufacturing, being able to do things without even needing to be physically present. That's one. And then two, having more flexible methods of doing things. All right. So let's look at how this applies to 3D printing. All right, so why still under why is it included in the fourth industrial revolution? We have increased production flexibility. Now, what does this mean? With 3D printing, a production plant can say, let's assume there's a 3D printing factory, for instance. They can say, okay, I've made this, and now I want to switch over to something else. Instead of having to go maybe carry their molds to China, tell them to adjust it, or buy a new mold and wait for it to be imported and all that, they can easily change what they are producing. So it increases production flexibility. It accelerates design iteration. Simply put, this means that anybody can work on something. So you can work on something, and whenever you want to, you can change the design and build and print something else. So it helps in prototyping. That's what the second point is trying to say. Imagine if I'm trying to design a bottle and I don't like the bottle design. I can say, okay, let me design a new bottle and then move over to that other one, print it, test how it works, and move again. So it's a very iterative process with 3D printing. It allows for optimized design with reduced constraints. Still on the design topic now, let's assume I want to design something that is difficult or maybe have some particular problems with it, with the geometry and stuff like that. 3D printing will be able to get it done because it is based on what you design in your CAD file that the computer will print. All right? Then it allows for, I'm hoping you guys can still hear me. I noticed that rain just left falling in my environment, but I'm hoping everyone can hear me. So I'll just move on. Okay, this is a very important point, and I would like us to take note of this because personally, I'm very enthusiastic about this. It allows for distributed manufacturing or local manufacturing. What does this mean? Let's picture a mechanic that wants to make the interior of a car, maybe the plastic handle or the of the door or radio compartment and stuff like that. So let's picture that kind of mechanic. Now, during this COVID era, he cannot import anything because the borders are locked, right? Or it will take a longer time and more money to import anything to the country. So what can he do? Now, if a company like Toyota is interested in distributed manufacturing, they would have their servicemen or their manufacturer or their mechanics around the world with standard Toyota 3D printers, of which whenever you need a product, all you need to do is download the digital file from Toyota and print it in your local workshop. So it localizes manufacturing. It doesn't have to all be centered around the fabrication plants or the manufacturing plants. it can have manufacturing in different spaces closer to the consumer or to the customer. All right. Then it enables for fully customized products. This is quite similar to production flexibility, just that this deals more with individuals having their own customized needs. For instance, you want a name on a shoe, or you want a particular type of jewelry and stuff like that. So it enables for fully customized products. Then you can print on demand, thus limiting need for inventory. Very interesting. Instead of having to print and stock up warehouses for a couple of weeks or months before customers can buy, you can print whenever a customer needs something, printing on demand. So you order in a few hours, they've made it for you and they send it to you. Instead of having production plants that run and take 2 days to turn on the plant and turn off the plant. Note that 3D printing is not trying to replace traditional methods of manufacturing, but it is supposed to connect with it. It's supposed to complement traditional methods. So in a place where traditional method would be too rigid, you can inculcate a 3D printer. All right. And then lastly, to reduce material waste. And this is the concept behind additive manufacturing. 3D printing is called additive manufacturing because it's a manufacturing process that builds upwards, while the others are subtractive, they cut through. So if I want to make something out of a block of wood, I would cut it out and have the rest as scrap. In fact, with metal, it has a name, scrap metal or scrap sheets or whatever. So with 3D printing, however, you build from ground up. So it builds layer by layer on each point that you have specified, thus reducing material waste. All right. So before, since we are done with the revolution, I want to go into the applications before we conclude. And what are the things that you need to know in the applications? Now, many people have told me about how they want to know what COVID-19 is doing. And I don't need to stress on that because we see every day on the news, we see Senegal making a $60 ventilator that you can 3D print. We see different companies doing different things. So I'll just touch a bit on what's happening around COVID-19 because this is a very challenging time for the world concerning 3D printing. So we have the printing of face masks, printing of respirators. This was done in Italy, and we have the printing of face shields. But what are the futuristic things that can be done in 3D printing? What are the things that we are excited about? What are the things that we look at and we say, wow, we are going to get here soon? I heard about one today, SpaceX, concerning 3D printing of things in space. So there are different things that are being done in 3D printing. So we have the 3D printing of food. This looks like it's far ahead, but actually many companies, and I would mention some of them, have found ways to print different food materials, just that they are limited by the kind of materials they can print and then the need for the food, because by that point it's exotic materials that you're printing. All right. And then we have the printing of houses. We all heard in China about the printing of a house in 24 hours and stuff like that. We also have the printing of organs. Now, this printing of organs is something called bioprinting, and it has made medical doctors really excited because instead of needing transplants and needing to move organs around, you can simply sit down, you sit your patient down, collect cells from him, replicate these cells, and then you can create whatever organ you need. But for now, they've not gotten to the perfect point where they can replicate organs for functional use, but they've made a lot of progress in terms of cells and tissues and parts of the body. All right, so that's on bioprinting. You can also research more on that. So I'm going to show you a short video concerning 3D printing of a house so that you can see what people are doing with 3D printing. This video is So here we can see the printing of the house. You see this took 24 hours working day and night. You can see a robotic arm working to get the arm. Yeah, this house is in Dubai. It's the world's largest 3D printer. So I know a lot of architects and civil engineers that will be very excited by this. They're like, wow, I see what can do 3D printing. People used to know before, you can print small scale models, but now people are going to printing houses that they would actually live in and are structurally acceptable thanks to the technology or the miracle of 3D printing, let me say it like that. So who uses technology? Now I want to tell you about companies that are directly applying it. We're not just talking about futuristic things or things that a few have been able to try with 3D printing, but these are companies that 3D printing is part of their process. One of the big giants in this is General Electric. General Electric even started their own 3D printing sector to show you how important this is to them. They are the makers of jet engines and aviation, and they're also in the healthcare sector. Now, how does General Electric use 3D printing in their jet engines? Normally, if you want to create parts of a jet engine, you would need to create small parts and then couple and so on and so forth. You put your bolts and your nuts and this and that. But with 3D printing, all these parts, which will end up being clumsy if you're connecting them and will have failing points and stuff like that, can be printed as a single unit, which is more efficient and lighter. Lighter in the sense that it wouldn't have all those bolts and all those things that will weigh it down. So it's lighter and thus much more efficient. And then they are the owners of, I just put this here for a bit of perspective, they're the owners of over 300 3D printers that they actively use. So this is to show you how important this technology is to General Electric. All right, Sonova. Sonova is a 3D printing factory. And this is very exciting for me because I like to see, I've always longed to see the words 3D printing factory together in one sentence. So a 3D printing factory is where they have a lot of 3D printers and it works like a regular manufacturing plant. So how does Sonova work? Sonova makes hearing aids which are customer specific. So it needs to match the ear, it needs to fit, it needs to meet certain requirements by the customer. All right. So they have a design team. When a customer comes, the design team designs hearing aids specific to that person, and then the 3D printing team then gets the print done, finishes it, and sends to the customer. So this is very exciting company that works on this. This is also another company that does a similar thing, Oral Arts Dental Lab. They also make these dentures specific to consumers, and then these dentures are this pink aspect that holds the artificial teeth are now given to their clients. All right, then Miam Factory. Remember I told you earlier about 3D printing. I think this company is in Italy. This is a company that 3D prints chocolate. So they are a big name in 3D printing in the country, and they are into printing of exotic chocolate shapes. So people that can afford them or companies that need chocolates for specific events and stuff like that can meet them and get this 3D printed of food. And note that this food is up to all food standards, any country's food standard. This food is approved, so it's healthy for consumption. We have Airbus. Now, I put this Airbus example here because they did not directly look for, they didn't directly look for 3D printing, like they needed it. There was no other solution, so they needed to use 3D printing. Now, what happened? Airbus has jets, and they're always looking for ways to reduce fuel consumption by reducing the weight of the jet. Now, in the process of trying to reduce the weight of the jet, they saw the partition between entering the jet or outside, or between the cockpit and the rest of the plane. So they saw this partition and they felt it was a waste of material. It was just a chunk of metal. So they decided to reduce it. How can they reduce it? They use a software called Fusion 360 to carry out generative designs. If you look at this, so these are two different designs that Fusion 360 presented here on the screen. And if you look at them, you see that they found out that they can use less material, thus making it lighter, and still achieve the same strength and efficiency. But when they had this, they did not know how they would be able to print it or make it. So they turned to 3D printing, because if you're using traditional methods and you make a single mistake in any point or stuff like that, it would affect the whole structural design. So they turned to 3D printing and they printed this shape. After printing this shape, they then created a mold around it, which they used for mass production. So they needed to use 3D printing to carry out this, and luckily the technology was available for them. Moving forward, we have Ford. Ford makes automobile cars and automobile parts. They use 3D printing for some of these parts and for prototyping in Ford Labs. So you can see the car here, which they can carry out their analysis on, check for fluid analysis and the rest. A bit technical, but just know that Ford uses it for their prototyping jobs too. And we go over to Whitehurst. Whitehurst is a company that works with jewelry, also customized, similar to Miam Factory that customizes their products. So you request for a customized shape of jewelry, and Whitehurst produces it for you, prints it out, whatever material you want, or whichever one they think will work best, and they give it to their clients. Simple as that. And then lastly, we have Boeing. Boeing Dreamliner 787 has been in the news a couple of times. Boeing, this is important to note, every Boeing plane has 30 3D printed parts, including air ducts and hinges. This shows that for every Boeing plane that leaves, they have at least 30 parts. This shows you how important that 3D printing is to them. They have at least 30 parts that are 3D printed. All right. So how can this knowledge be applied? And I know most of us in Nigeria are saying, yes, 3D printing is cool. You've told us how it works, but how can it be applied? And before I answer that, because I have a couple of things on how it can be applied, I would like you to know that I don't want to limit us to just what can be done in Nigeria. In my opinion, we need to focus on what can be done internationally. We need to focus on what people are doing, because the world is getting digital. We can't hold on to only what is happening in Lagos or in Abuja and Port Harcourt. We have to go, or in Benin, as Usefull Tech is in Benin. So we have to go around what's happening around the world. We have to keep up with their latest research and technology and stuff like that, and join the global revolution. Right? But for what is happening in Nigeria, I would tell you, you can design prototypes for 3D printing. That is a very popular thing. So there's something called Thingiverse. This is a repository that has a lot of models. So people design there, and when you design a model and post on Thingiverse, you have the license. So anybody can download it, but if they want to use it for commercial use, they have to pay you for that license. All right? And so that's just one way you can use 3D printing. You can also use it if you're designing for companies or for organizations. So yeah, you can work with organizations who have 3D printers and prototyping. At the point, Tranos in Lagos that I know of had a 3D printer which they were using for prototyping for their clients. So if any organization that owns a 3D printer in Nigeria will be very excited to hear that you know how to 3D print or you understand the technology. Then you can also promote your skills to assist applications and improve your CV. And this is very important. Many people say, yeah, it's not all about improving your skills on your CV. But the truth is, this technology is being adapted around the world for different uses, different functions. And people want to know that you know what you have something to offer. So if you can build these skills, you can measure up wherever you go, whether it is in 3D printing research or to work in their industries or whatever. So this is an opportunity for you to gain knowledge on the technology. And then purchase of printers for prototyping. This is the most obvious and working on projects. So yeah, you have the 3D printing technology. You should be able to say, okay, I want to work on a project and I need to make a prototype. It quickens the process, it gives you flexibility, it does so many things, as I mentioned earlier. And yeah, you can also use 3D printing services. There are a lot of them in Nigeria. So 3D printing service is just a place where they own 3D printers and they can print for you. Usefull Tech is one of them. If you just search 3D printing in Nigeria, you'll see a lot of 3D printing services available depending on where you are in the country. All right. So how can you work towards mastery? If you want to learn how to use this technology, how you work towards mastery, we'll start with CAD modeling, because it's always very important to create your own designs, not just downloading designs to print. It's very important to know how to create your own designs. Moving on, you then use the slicing software, which prepares those designs, and then you print. So those are the milestones that you need, and then you learn how to work with the 3D printer. You understand its hardware. You learn how to fix it, service it, maintain it, and stuff like that. So it's a series of processes, and I will show you an example. This is a project I prepared for somebody in the spirit of Valentine's Day. A client told me, can you help me make a pendant? He wants to give it to somebody. And I was like, okay. So he gave me a sketch of what he wanted. He was trying to be creative with the design, and I made it in Fusion 360. I prepared it with the slicing software, and then I printed it. There's a short video of it printing. I don't know how fast the video is, but I slowed it down just so that you can see the printer move. So it is at the last layer, is just trying to complete the print. So this is a 1-hour duplicator i3 plus printer, and this was the finished product. So here's the printer. There's the printer in my hand attached to a necklace. All right, so that concludes our seminar, and that is all I wanted to know on the revolution, the technology around 3D printing. More on Usefull Technologies. So I'm just in the 3D printing department, so to speak, of Usefull Technologies, and they do trainings and stuff like that. They have 2 sets of trainings: 3D printing, introduction to 3D printing. I said that word a lot, so it's starting to have issues in my mouth. Introduction to 3D printing, and they have intensive trainings on 3D printing. So the introduction goes far deeper than this. This is just touching the surface, goes far deeper than this. However, the intensive training would you would come as an expert in the technology and be able to use it anywhere you want. So depending on what you need, you can then opt for whichever training you want. There may be virtual trainings during this era of COVID, but I don't know how it's going to be. This is a picture of a print from one of our trainees of last class. And this was what so she's in architecture, so she printed her school model. So she's a student in Department of Architecture. So she printed her school model for her school project, and it was an interesting process. Then she coupled it and finished it. All right. So step inside the anything factory. This is what GE says. This is GE's statement. So General Electric, being one of the leaders in 3D printing, has a sector called GE Additive Manufacturing. And with that, they have what they want to achieve. So GE's statement is that they want to create anything and they want to give other people the ability to create anything from their imagination. You can read the statement, it's here on the screen, but I want to leave you with that. The point of 3D printing is that with the right materials, with the right technology, with the right skill set, you can build anything you can imagine. All right? Thank you. So are there any questions? I hope I wasn't too fast.
Okay, Alex, thank you very much. You were not so fast, at least I mean, the pace was very good for all of us. Myself, I learned a lot, and although we've been together for long, but I really learned a lot today. So I think it's good that everybody unmutes themselves now. So you can ask your questions one after the other. So Alex is going to handle that. But Alex, there's a question here that, I mean, someone asking if there's going to be any training anytime soon.
Okay. So I think that's up to Usefull Technology, but we're supposed to have a virtual training and probably physical trainings when this COVID is over. So hopefully the pandemic will be over soon. We are being optimistic, but I guess it will be communicated if there will be any. But keep in touch with us and more information will be spread.
Okay. So any question? We're here to take questions now. So yes, can everyone unmute themselves?
Yes, Barry.
Yes.
How much does it cost for the training?
For the training?
Yes.
Yes, the training now. I mean, post COVID. Yes, we are going to maybe retag the price of everything. But before now, the training used to be for 30,000 naira.
Okay.
Yes. So yes, but if we're going to have anyone soon, it's not going to be up to that amount, because yes, we also thought about reducing the cost for students.
All right. Okay. I wanted to ask again. You said they use plastic as the material, right?
I think that question goes to Alex.
Yes.
Okay.
So
if they want to print, like for example, those jet engine stuff, won't they not use all those aluminum material?
Yes, so I think we should go back to 2010. So I told you in the history that from 2010 to 2020 that we're in, they started multi-material 3D printing. So they started having metal and multi-material. So now there are standard metal 3D printers out there that are very efficient, very popular, though they are still a bit expensive. So most times you would see plastic printers because those are the types that are affordable. Those are the types that you can easily purchase and use, but metal 3D printers are very, very popular.
Okay, thank you very much.
Thank you.
So any more questions? Who is having any questions? So we tackle all this. You can all unmute yourself. Emeka, you are
Hello,
still...
can you guys hear me clearly?
Yes. This
Hello,
is
can
Ehi.
everyone hear me?
Yes.
Yes, we can. Hello, Ehi. Are you there?
Yeah. Can you guys hear me?
Yes, we can.
Okay. For the model on the building model, like how long did it take? Because that I want to present that took a long time to print. How long did it take to print? That is the one you did with Mary Ann. when you showed
Okay.
us?
It took about 2 hours. I would say it took
Two
about two
hours.
hours, yes. But
I was thinking like a
another,
whole day.
no, it didn't take that long. However, if you want to achieve like very good finish, you have to work on it a bit more than that. But the printing itself took about 2 hours. Yeah.
That was nice.
All right.
So any more question? Any more question? We still have some time. Yes, we still have 5 minutes. So, but anyway, if there's no question, I think I'll have to say some things. But feel free, you can type your questions. I'm going to mention them to Alex. So, but to end up, we just to mention what we do at Useful Tech. That yes, we offer trainings. We also is a tech company that offers services in digital skills, tech solutions, and also digital products. But you can also follow us on our YouTube channel to get this video after now. So for those of your friends that were unable to attend this webinar, yes, you can tell them. I'm going to send a link to everybody via mail, and feel free to forward it to your friends. Yes, I just sent the Facebook handle, so you can also use that. You can also search for Useful Tech on LinkedIn, on Instagram, and also on Twitter. So we're very active on these handles. So you can also ask your questions there. If you don't have any question now, but you feel maybe after now you're going to have some questions, yes, it happens. So feel free to ask your questions, and Alex will be ready to answer your questions also. Yes. So welcome everybody. Welcome,
Thank
welcome.
you.
Thank
All
you
right.
once again. Okay, bye.